Sentosa, Singapore here. And we just finished an operational technology cybersecurity conference here. And I'm very pleased and very privileged to have Marco Ayala all the way from the United States.
All the way from the United States, Jane. So I'm very happy to be here, finally, to be able to be one of your guests. I am a big fan.
Oh, thank you.
Yeah, and I have to say, you have some very exciting and interesting episodes.
All right, I'm sure that this one will be one of those extremely exciting ones.
I think it's already started that way, for sure.
Right, and you're going to be sharing with us the latest trends and developments in operational technology, cybersecurity.
Yes.
But for some of our audience who are not too familiar with this space, right? We tend to think of operational technology and critical infrastructure as isolated buildings with like power treatment plants, water treatment plants, electrical grids, power plants, right? Smoke chimneys and electrical wires, but it's not like that, is it?
Well, it actually is. I mean, the operational technology that keeps these plants running, or these orchestras, as you pass by a facility and you're seeing steam come out or valves open or close, that's all being done from programmable logic controllers or some type of cyber physical means. And so that operational technology is much different than, say, your cell phone or your mobile. It does have compute, but the thing is it actually ties to physical elements, whether that's valves, pumps, things that keep the world moving. And so even electrical grid, keeping power to your homes, it's not just three wires that are just powered up. It takes generation, it takes controllers to be able to produce the electricity that you even see and the water that you drink. It completely relies on operational technology. So think about them as sophisticated computers with a dedicated need, and that is to operate critical infrastructure in near real-time or real-time operating systems.
Right, and I think for some of our audience, a good analogy is to think of it as like a mobile phone, but it's a very, very sophisticated mobile phone that's got very specialized function, and of course has, if it malfunctions, it has physical impacts.
It has specific applications that are for cyber physical, so you won't have Outlook or email or Google or any of these things that are remnant in the operational technology systems. These are going to be really system hardened, where only these specific applications that are designed, tested quite thoroughly to be able to run today's operations is the key differentiator. It's not just a standard type mobile phone. And it's not your garage door opener that are just kind of commercial off the shelf. These are systems that must run, must not fail, and have a mean time to fail over many numerical numbers to be able to keep operations going, keep water flowing, for example.
Right. So, and when we think about safety with this critical infrastructure, right, we think about floods or natural disasters. I think immediately comes to many people's minds. But cyber risk, of course, is relatively, compared to floods and fires, relatively new. And one of the framework that you were, talking about earlier is cyber-informed engineering, right?
Well, so Tim was on talking about the cyber-informed. I talked a little bit around CCE, which is consequence-driven.
Oh, sorry, consequence-driven. That's what I meant.
But the one that I was really focused in on is a global standards approach, and that is the ISA, or International Society of Automation 62443. Standard, also recognized as IEC, the International Electrotechnical Commission standard. It's a global body. And so those standards are specific to industrial automation and control systems.
Okay.
Yeah.
And I think your approach really prompts engineers and cybersecurity professionals to think about the high consequential events.
Correct. Yeah. So being able to even look at situations where it's a low frequency, high consequence event is very important. But being able to identify not only the systems that you have and the not only the network architectures and the devices that are on the network, but understanding what their actual function is, what they're controlling, how they're connected, and if a cyber aspect was able to get into, whether it's targeted malware, be able to manipulate, modify, change, or inhibit or reduce the action of the controller, then that could have some major impacts. So the whole idea is system hardening, network hardening, but making sure that you're following some standards-based approach for security in these operational technology systems.
Okay, I think one question that the audience might have is that, all this critical infrastructure, right, has very diverse components, right?
It does.
And a lot of them perhaps are running on legacy sort of infrastructure.
Oh, absolutely.
And of course, critical infrastructure, when you talk about the operators, you're talking about the field engineers, you're talking about, the engineers.
Maintenance,
right?
That's right.
So, and of course, you have cybersecurity professionals, right? So you have a diversity of talent, you have diversity of components, diversity of, I guess, longevity of the equipment. How could you get people to agree on, what are considered as high consequence, even low frequency events? It could be very, very complex.
Well, so many of the process industries do follow some form of even process safety management. And so those industries that have high hazard, high consequence initiating events have to track these using process safety management. So they already know that they're trying to mitigate loss of containment or fires or explosion. So they actually go through a process to be able to determine what that is, how it can get to that state, and what they can put in to be able to reduce or remove or limit the ability for that event to even trigger or to happen. And that could be not only digital means of control, but also maybe a separate isolated safety system, which again could be digital, or even failing over onto mechanical devices such as relief valves or valving that would open up mechanically if there was a high pressure event, for example. And so a lot of people that are doing that and following process safety management understand their risks already, but they don't understand the cyber component, how cyber could be a mechanism to remove their safeguards that they have taken credit for. And so that's the whole idea in the process, whether you're looking at this from a standards-based approach or process safety management, is assessing, correlating it to your process safety management for those high consequence, low frequency events, and determining if what you're doing for your cyber physical operational technology is enough.
Okay.
Yeah. I know it sounds like a lot, but
yes, I'm sure that it's very complicated in real life when you kind of start doing.
Well, so let's talk about that. So complexity breeds. It actually, when you have complex systems, those inherently breed vulnerabilities. So the less you can make your complexity, or the less complexity of your operational technology from a mitigation standpoint, is actually easier for the person that's deploying security around it. But when you have complex systems and complex networks, you may have multidisciplinary people touching those systems, and you can't control that unverified trust. And so sometimes complex systems can be complex within their own realm, and that's not always good in operational technology.
I think another question that our audience might have is that it's not just the complexity of the system, but say we go through this risk assessment framework, but at the end you come to this kind of decisions that's equally risky, right? So talking about vulnerability, right? You can either patch your legacy equipment or you can update it, and sometimes it's equally risky, I imagine.
It definitely is.
Yes.
It definitely is. Absolutely. There could be impacts to deploying a patch on a system even during downtime to where it could not function or could be inoperable, which doesn't help your case. So some things that you can do for legacy systems whenever you have these probabilities for cyber would be a really strong defense in depth strategy, limiting access, limiting, constraining who has access when, maybe even not allowing remote access into the legacy systems, but allow secure access into some of the newer systems. So we have to be very cognizant and very strong in how we're doing this from an engineering perspective. Because there's just too much risk to just allow systems to connect to the internet, or even directly to or indirectly through the enterprise, and just think that this is an IT problem. It's really not. It's an engineering problem.
Right. So coming to my next question then,
Oh,
right?
okay.
So you brought this up, whether it's an IT problem or engineering problem, and I think it's one of these themes that we hear during this kind of operational technology, cybersecurity conference, which is the language and the communication gap between the engineers and the cybersecurity professionals. And you have been an engineer for what? A long time,
I've been
right?
in the field for some time.
For some time. So I'm sure that you have seen the evolution of how the two groups are coming together, working together.
Yes.
Can you tell us, how
Yeah.
you've seen the evolution, how it has improved, and what more would you like to see?
Yeah, well, one of the things that I am very proud of is the International Society of Automation. And so they also have safety and process safety and alarm management for operations, for this operational technology. And so the folks that are going and getting trained and certified in certain areas there also have the ability through ISA to even take cybersecurity classes and be certified. So getting these different disciplines to communicate and talk and collaborate has become much easier through organizations such as ISA. There's other organizations out there as well that do the same thing, but I think it comes down to collaboration. And Jane, I have to be honest with you, it also comes down to diplomacy. Working with different groups from process safety, engineering, maintenance, operations, supervisor to all the way to the C-suite, it takes a little bit of not only the know-how of the language that they speak, like business risk, as opposed to process safety risk, can sound very abstract. So you need to, in your efforts to get all the folks on the same page and to communicate, is to have someone as a champion or liaison, or a couple people that are liaison that can speak all the languages. So think of like the Tower of Babel. Everyone was speaking a different language. When it comes down to risk management is risk management. It's just how you go about it. And so I think I've been very successful working with different groups, different isolated or siloed groups, just by getting them involved and having open dialogue with them.
Right. And ransomware, of course, have been quite prevalent, right?
Ransomware has been on the uptick. And the concern with ransomware is it only ransomware? Is it only that, or is it a dual-faceted, a possible attack? I mean, could there be left behind some nuggets of command and control or some other stage gating? So it could be ransomware plus, right? And so we have to be very careful with that. And ransomware has been targeting not only IT, but we know that there's been either indirect or non-direct impact to operational technology, where Windows systems that are used in the OT space could be impacted or locked out or encrypted. And backup policies and procedures in the OT environment may not be as mature as those in the IT environment. So it depends. It depends on the asset owner, it depends on the company, and depends on the culture for those facilities. So I say that, we're, especially with all the geopolitical tensions that we've been dealing with, I think we need to protect the operational technology systems even more so than what we were doing 5 years ago, and take all these early warning indicators, whether it's ransomware or what have you, to be able to keep those from getting into our most critical, most precious systems that not only keep us safe, but keep us alive, right? So think about that from a medical OT perspective. If the systems are compromised or ransomware and now you can't even operate, you're having to send patients somewhere else because your hospital or your clinic is not able to process or even work any of the equipment that's part of the actual operational scheme.
Right, and resiliency, of course, is a big part of this backup that you talked about. That is still relatively.
It is
nascent, I guess.
It is. It really is. I mean, resiliency is exactly that. Is you've got to be able to not only build out your systems resiliently and test them but make sure that you have an ability to even operate even in a degraded mode in case there is some type of cyber breach. So that could mean disconnecting from IT. Can you do that? Is it possible to operate the operational technology? Some companies, yes. Some companies, no. Some companies say yes, but they don't even know where that communication link is to be able to even be pulled. And then there's always fear that if they did pull it, what else would fail? So we're so intertwined with our infrastructure digitally, this major infrastructure and this data lake that we have, that we just have to be very careful and very cautious. So that's why I was talking today at the OTCEP on risk assessment and tying those to process hazard analysis and layers of protection analysis. Mm-hmm. Yeah.
I know that the approach will be very tailored to specific industry and, depending on the kind of equipment that you use. But is there like one top priority that you like the operational technology or cybersecurity professional to really, focus on?
Well, I think identifying vulnerabilities, but the one thing that folks need to focus on is their architecture, their design, and any remote connections into their system, whether these are agreed upon. Make sure that folks are really documenting these out, understanding, and also logging and getting visibility into their networks without impacting their operational technology. So understanding the data flows within the environment, who's talking to who, and on what port, what protocol, especially in the industrial space. And being able to understand when those are happening and who's on the other side of the keyboard are pieces that you should be trying to identify in your structure. And then the other thing too that I think is very important, Jane, and I'm very passionate about is training, cybersecurity training for control systems and operational technology. And ISA is I'm a certified instructor for ISA for their cybersecurity certificates. Training, and there's 4 classes. One's introduction to the standards, and then the other is risk assessment, design and implement, and then run and maintain, which also includes incident response, backups, restoration, good engineering practice. Yeah.
I think a lot of the audience will probably, understand this when, it's they start using, say, for example, electric vehicles. It's when it becomes more widespread, and you kind of start to realize that you need to factor in the cybersecurity aspects, right? It's connected devices.
It's a connected device
with physical impacts, right?
Right.
So it's no longer just a mobile phone with maybe
right.
some information leakage. But
I think very much so. I think it was. Trying to remember the gentleman's name. There's two folks in the U.S. that were able to get in through the Infotainment system in 2014 or 2016 into a Jeep, an American brand vehicle, through the telephone carrier, cellular, into the information or the Infotainment center, like where you get all your streaming songs and what have you, and we're able to accelerate, be able to brake. Apply braking in the car, and also adjust with the steering wheel. And there's a video on that, but that's the digital world in reality. And obviously, it was not purposely designed to do that. So these are just flaws in code and flaws in deployment,
which has been could be exploited by threat actors with malicious gains and.
Absolutely. Yeah, and that's what we need to worry about is what we think is secure today may be insecure tomorrow. And that's what we have to be very cautious of, especially in the space that I'm in, and the making sure that we have some type of reciprocal life cycle where we're just constantly making sure that our systems are as reasonable as possible, up to date, even in legacy systems. And if they can't be, we need to come up with compensating controls to be able to reduce the likelihood of a threat actor coming into that environment.
Right. And with cybersecurity conferences and podcasts like these, we tend to talk a bit too much about the threats and vulnerabilities. So I like to end the podcast on a positive note.
Okay, we can do that. Sure.
So what excites you about this space?
Great question, Jane. So I think what excites me in this space is that we have a lot of new workforce people coming in different age groups into the space. It has been for many years, focused in on, certain elements, certain groups. So it's great to see new talent coming in from colleges, and getting into the workforce. So that excites me because many of us older folks, we're going to be retiring at some point. So we need to backfill and train those. So that excites me. Some other things too is that we're seeing countries and governments that are becoming even more cyber defensive. And so we're seeing regulatory requirements come in, but also working with these asset owner operators to help boost their security. So that also excites me, is that we're not just neglecting it, we're doing something about it, Jane. And the ones that aren't doing something, I think at some point they'll have to. Mm-hmm. Yeah.
And of course, this podcast is also one way of educating and bring awareness to the general public about what we are doing in this space, right? To secure everybody's digital sort of lives.
And it really is a team sport, Jane. I mean, cybersecurity and security around operational technology truly is a team sport. And the more you know, the more you can do.
That's right.
The more educated you are, the better decisions that you can make.
Yeah, every one of us has a part to play.
Every one of us does have a part to play.
Every one of us has a mobile phone.
Or a mobile phone, or maybe some controller that does something at their home or their house or their facility. Correct. So yeah, absolutely.
Right. So thank you so much, Marco, for sharing, your insights. And
I'm very happy and pleased to be on your show, and I hope to come back.
Yes, I hope next time when we speak, we see tremendous